Okay, good afternoon, everyone. Today I'm going to present to you about the Smart Sustainable Cities ICT infrastructure, and this is what we're going to see today. First of all, I'm going to give you the brief definition, what is the Smart Sustainable City, and also for the motivation and challenges. And you're going to see the SSC infrastructure and also the cloud and fog computing for the SSC. Yes, let's start. This one is a definition from the ITUT, like I already give you some information. So I'm going to sum up for you that a smart sustainable city is a city that uses the ICT information that has intention to improve the quality of life of the people inside the city, which also concern about the economic, social, and environmental aspect. And this is the 5 key technology group inside, as seen in the slide. But my work will going through only for the telecom player and energy and infrastructure. For the telecom player, like we're gonna see that what kind of a network and the design that is suitable to use in this SSC, and also concerning about the monitoring, sensing, and also the security. And for the energy and infrastructure, like because the smart city is a part of a miniature of a microgrid, so we're gonna see many applications that include for the smart grid, and also we're gonna talk about the renewable energy and some automation system. And this is a 5 key technology. Yeah, these 6 enabling technology and challenges. I'm going to brief to this. The first one will be about the networking and communication, because we're gonna connect everything to this kind of a network. So this network must be able to support many complex of protocol and technology, and also use the low power. Next one will be about the cyber physical system and the IoT. We're going to concern about since we have many weak points to the network, so about the security issue and also for the data policy, we'll be concerned about this. Next one is the cloud edge computing, because cloud is a technology that is very suitable for the SSC. It can support the high volume and real-time data. So this one we're going to figure out what cloud infrastructure is suitable for us. Next is about the open data. Because we're gonna have many kind of data in this one, but we gonna need the data sharing between each stakeholder inside the city, and also that the question will be that how to encourage them to share all this kind of data together. And next is big data and data analytics. Since we already have the big data and CC for the sensor, but we're gonna try to figure out that what kind of information the city needs, so we can compute by using the data analytics to improve the efficiency of a system in a city. And last but not least is the citizen engagement. And because the smart city is about the people, so we need the user-centric approach. So the goal will be to design ICT's framework for smart sustainable city. And this is what we're going to see today is a smart sustainable city infrastructure. As you see on the left side is an OSI layer which we already know in my field. Yes, and this one is a new framework proposed by the ITUT. You see that at the lower we will have a sensor layer. This is a new one, and we try to connect all the physical infrastructure like road, buildings, vehicle, and people, and we try to get the data through the information technology with the IoT, that you can use the RFID, GPS, SCADA, or whatever, and try to gathering all this information and try to digitalize it through this one, through the communication layer using optical fiber, mobile broadband, or the internet inside the city. And the data will go through the data layer. You see here, you will have many types of database inside. This one is a shared resource. Yes, and this one is a cloud computing, and this one is for data analytics. And the upper layer will be for the application. Application will create by each of the stakeholders, and also all the players inside the city that try to want to engage the citizen that use the application and get all the requirement and data that they need. So if you want to be successful in implement the smart sustainable city, you're gonna need this sensing layer, and also you're gonna need the computation layer here. So this one is going to talk about the cloud and fog computing. Let's say that we have many kind of sensors spread over the city within a huge area, and we try to connect from each user through maybe their IoT device. So let's say that we have thousands or maybe millions of sensors that try to connect to the network. If you have only the cloud at the centralized network, that means that you will need to send the information from the sensor through the network. It takes some time, and also done some computation and sent to the other sensor. So that means you get a huge latency here. But if you have the fog computing, because it's an extension of the cloud computing, it's more closer to the user, right? To the sensor and user at this one. And they will have like a small resource and small computation system, and they will do a local computation for you. That means the sensor will send the command and the data. You can compute it here and can respond in the time. And also, if you want to communicate between each sensor, between each fog, the fog will transfer all the data between each other. So in this scenario, it supports latency awareness application. It's more suitable for some smart grid application like a demand response or maybe some metering system. And to design this architecture inside the city, we're going to concern about the four principal method here. It's about the openness, because we want to connect all the multiple vendors inside the fog network together, and they must be compatible with a third-party application and can be accessed by anyone. Second will be the data app-centric model, because we want advanced policy management to manage all the data sharing and data workflow inside the city. Next is the virtualization and bug consideration. We're going to need the management and deploy service autonomously at the Fox node. And last is a uniform management and service consideration, because you're going to have the fog spread over the city, so you only need one point that you can deploy all the command, and all fog node got the same. Okay, so it saves time, save money, and save your operation costs. And this one is a new era fog computing, as illustrated here. I separated into three main components. This one is a fog node. It will be installed inside the cabinet. And this one is a back-end cloud support in the center of the centralized clouds. And this one will be the cross-domain function to try to manage all the security issue management or the networking system. And I'm going to present only for the fog nodes. Okay. For the fog nodes, we will have like the VDs inside here. It's application specific on the virtual machine, data management and data analytics for do local computation, and the gateway to communicate with all the sensor in the physical layer. And in case they want more information, they can go through the non-bound interface to access to the cloud. Yes, and this is part of my presentation. Thank you.
What city using this system? What city using this system?
Okay, so this system is proposed by the city of Barcelona, but I'm gonna try to use that framework and adjust to my headquarters for ECAT, yes, for this model.
What is protocol in IoT?
For the IoT, you mean this one? You can use many types of protocol. It's up to the sensor that you want to use. You can use Wi-Fi, Zigbee, or anything. Yes. So that means that if you want to design this part, since my work is will concern about this communication layer, like the interface here and some of here. So this one is I got to receive the requirement from the department that they control all the buildings, like smart energy, smart buildings. So they gonna tell me what type of the sensor network that they use and what the system inside. So I can design a network that can support that kind of protocol.
The energy network reliability is mean that everyone can create and generate electrical power and just like the network.
I still wonder that the data layer will have to divide the database into different types of
First one is the electricity network.
This one?
We have 4 sections.
This one? You mean this one?
no, for the database.
Electricity
For the
system.
database
One is
here?
Generation system and storage.
Why you
Another one
have to
is the
divide it
unit
up
part
like
of
that?
and important transmission
Ah, okay.
and distribution. One of part of
Okay, in this infrastructure, you will see that they have divided, like also, yeah, this is a virtual right, but they also have to separate the information because all the information will come from the sensor, and they try to categorize it to use in like this one is for from the GPS system, right? So that means that they can match between each one, yeah, to create a new type of the information through cloud computing.
So to serve the application here, application
Is that answer to your question?
which is
And another part is because in one city, you're gonna have many departments that own this type of the database themselves. So also that is shared, but there has you have to also separate the data
the role of communication in
because each department will be responsible to each type of data. Yeah.
In power
From that,
utility.
I'm not sure that I
Reliability,
understand
which means that we have to
correctly
build a
or
global
not.
network
So
that
the
has
database will
availability,
connect, like will connect
Which means that
each
it
other to
connects
the
to any disruption that will occur in the
This
system.
one?
The second one is the
Yes.
confidential and authorized.
Because
So it means that
in
you have to
this
control
slide you see that
your own communication system. You shouldn't rent
Yeah.
the service
Um,
from TOT or from
the fog node will
that
also have the small data management,
The last thing is
and
to serve
this
the
data management will gather from the sensor as well,
application which not
like
in
the
same
manager of the
application as
database in the
other
cloud,
one.
and they also can sync and get the information here at the same time. But also, this kind of data will also limited, and like it's up to that what kind of the network and sensor in this area that they gonna use. Not all type of the database will be in here. Mostly will be in here, but this one only for the necessary one to compute the local computation.
Which is the optical fiber. So the equipment that will help you to
So
transfer
your work is to provide
the
and
first
to
one is
design a
the
platform,
either or SMS,
Yes.
right?
Yes.
So I'm wondering if, I mean, how can you compare? If I have another designer, you can also, propose a conceptual platform and all these things. How can you two be compared?
Okay, to prove my concept, I will set up some miniature simulation that have the component inside the CD that refer to my headquarter office.
It should be scalable as well.
Yes, it should be scalable, but because my phase now is about getting the requirements and try to get the more information about this,
every device has to
yeah, from my organization, so I can get more clearly that how many systems that they want to use, and I can decide this one.
Yeah, as like you, so if you have any candidate that can also meet the requirement. If I'm an EGAT, how, I mean, what criteria should I use to select, you know, the best platform.
That is communication.
If all of them can meet the requirement.
This is what
If all of them can meet requirement, you mean that they can meet the design and delay time, right? Because we're gonna talk about some of the micro grid application. If in that case, because I'm also from the planning department, so I have to try to compare in the economical way too, and try to match that is that a product in the market that's suitable for this for this model or not.
So you're going to use economical criteria. But what I'm talking about is more like technical, you know, performance.
Yeah, but you already said that all the architecture that can meet my requirement, right?
Yeah, but still, everything, all the choices meet the requirement, but there should be something that can be measured that, I don't know, in terms of, in terms of energy, speed, or those kind of things.
Okay, but for my current information, I just know that they're gonna implement the micro EMS inside the smart city and try to do like a real-time pricing model. So maybe I can test with that one and find what the architecture is the best. Also, they can meet all the requirements, but which one is the best that gives the response time.
Yeah, but my question is more like, what does the best mean? That's
Is the fastest the most reliable or the security?
Yeah.
What should be?
Okay. In this case, I have to say that my network is concerned about the reliable about the 99.99%. Is for the quantitative result. Yes.
So I will give you an example of one type function.